Hi everyone. In this lesson we want to talk about linear inequalities. And solving a linear inequality is very similar to solving a linear equality. So I want to look at just a few little examples right here to explore how an inequality differs from an equality. Well, I know that negative 6 is certainly less than 4 because it's to the left of it on the number line. And if I were to add 2 to both sides of this inequality, I'd get negative 4 on this side, and I'd get 6 on this side, and negative 4 is still less than 6, right? So the inequality does not need to change. If I were to add a negative 2 to both sides, subtract 2 from both sides, I'd get negative 8 on this side, and I get 2 on this side, and negative 8 is still smaller than 2. So the inequality is correct. It hasn't affected that at all. If I multiply both sides by 2, I'd get negative 12 on this side and 8 on this side. And all I did was make this side more negative and this side more positive, and so the inequality is still true. And so the inequality doesn't need to change. But notice, if I were to multiply both sides by a negative 2, I would get 12 on this side, and I would get negative 8 on this side, and 12 is not going to be smaller than negative 8, is it? And so in that case, if I want to have something that a true statement, then I would need to reverse the inequality. And so that's a little reminder that if you ever multiply or divide, because division's really just another way of multiplying, if you ever multiply or divide both sides of a inequality by a negative number, then you absolutely positively must reverse the inequality. Okay, so let's look at an example here. I've got this inequality, and I'm going to solve it just almost exactly like a linear equation. So I'm just going to go ahead and distribute the 2 here to the 4 and the 2x, and over on this side I'll distribute the 3. And the only thing I have to remember that's different about the inequality is if I ever multiply or divide by a negative, then I just have to remember to reverse the inequality. So I'm going to get 8 here plus 4x is greater than the 2x plus 6 minus 15x. Then let's collect my terms. Got some common terms over here on the right. I can write that as 6 minus 13x. All right, and so now what I could do, I can do one of two things. I could bring get all my x's over here on the right. That's the way we typically would like to do it. Let's go ahead and add 13x to both sides. And if I want my x on this side, I want my numbers on the other side. So let's go ahead and subtract 8 from both sides at the same time there. So that's going to give me what I'll get. 17x on this side is greater than, and then I'll get 6 minus 8 is negative 2 on this side. And then lastly, all I have to do is divide both sides by 17, and that would give me my answer, right, that x is greater than negative 2/17. Now notice there was a negative on this side, but the number I divided by was 17, so I didn't have to reverse that inequality. Okay? Now the other thing that I could have done right here is I could have, if I wanted to, I could have brought the 4x over on this side, right? It doesn't really matter what side your x ends up on. And I could have subtracted 4x from both sides. That would have given me negative 17x over on the right-hand side. And in that case, I would have wanted to take the 6 on the other side. So if I subtract 6 from both sides, that would have given me 2 on this side. All right. So when I do that, notice now I have a negative. If I want to get x by itself, I'll divide both sides by the negative 17. But when I do that, I have to remember to reverse the inequality. And so I'd get negative 17x over negative 17. That's x on this side. Oops, I should keep my color there the same. And then I have to reverse this inequality. and I'd get negative 2/17. Now notice that that did work out. This right here is actually written in what I call Hebrew, because you have to read it from right to left. So this is the same thing as, right, I've got my x, and my x is greater than the negative 2/17, which is what we got over here. So obviously the way I did it first was I think a little bit easier in that case. But typically you can avoid dividing by a negative by shuffling your x on the side that makes it positive. Okay, so one last thing here, if I wanted to write my answer in interval notation, so this would be, if I want to think about this, always visualize that I've got an x value, here's 0, negative 2/17 is over here to the left of 0, and I want all the x's greater than that. So that's going to be all of these values. So in interval notation, this would be the interval from negative 2/17 to infinity, and that's how I'd write my answer to that. And remember, that's a whole set of x's that'll make this original equation true. Okay, one last example here, or at least another example. In this case, I look at this and it's like, wow, I have a fraction, and typically we want to multiply here those fractions, but in this case the fraction, the denominator is negative, and so this is an instance when we're being forced to multiply both sides by a negative. So I mentioned earlier, you can typically avoid multiplying by a negative or dividing, but not always. So here's one of those examples. So I multiply both sides by negative 3. That's going to cancel this negative 3 on this side, and I'll just get 2t minus 9. And over on the other side I'll get negative 21, but because I multiplied by a negative, I have to reverse that inequality, and it becomes a less than or equal to. So then let's go ahead and add 9 to both sides of this equation. So I'm going to get 2t is less than or equal to a negative 12, I think that would be. And then if I divide both sides by 2, again, I'm not dividing by a negative, even though there is a negative on the other side of the inequality there, my t is going to be less than or equal to a negative 6. So again, in interval notation, I'd want to visualize this way. Here is, here's my 0, here's negative 6 over here to the left somewhere, and I want the t's that are less than or equal to. So that's going to be all of these guys to the left of negative 6. So in interval notation, you remember, I always start at the left-hand side where it starts, which in this case is negative infinity, and then it ends at negative 6. And I want to include the negative 6 because it's less than or equal to, so I use the square bracket. And then I have the parenthesis on negative infinity because it's not really a number, it just means it keeps going that direction. Okay? Alright, one last problem here using function notation. I have one function that is 0.4x plus 5, that's f, and another function g, 1.2x minus 4. And I want to find where g of x is greater than or equal to f of x. So really all I need to do is I want to know if I want where g of x is greater than or equal to f of x, just substitute, right? G of x is 1.2x minus 4. I want to know where that's greater than or equal to f of x, which is the 0.4x plus 5. Okay, so again, let's just get my x's on one side. Let's go ahead and subtract the 0.4x from both sides. And at the same time, that's gonna bring my x over on this side. Same thing as grabbing that 0.4x, bringing it over here and subtracting it, right? That's gonna give me 0.8x. And then I'm gonna want to get rid of this negative 4, so let's add 4 to both sides. Again, that's the same thing as just dragging it across the inequality, and it'll change signs, become a plus 4. So I end up with 0.8x is greater than or equal to 9. And then I just have to divide both sides by the 0.8. Okay, and so since it's a decimal, I can go ahead and give my answer as a decimal. So my x is going to be greater than or equal to 9 divided by 0.8, which is going to be x greater than or equal to 11.25. Okay, so again, in integral notation, if you can visualize what we did up here, I'm going to have all my x's that start at 11.25, and they're going to go to infinity, and I want to include 11.25, but I only put a parenthesis around the infinity. Okay.